All right, good day. Welcome to today's class. And before I proceed further in what I'll be teaching you today in MTH102, we are still on the topic differentiation. And I would like to tell you this that you should go back to the previous live video we had earlier on differentiation because I'll be continuing from where I stopped in the last class. So please make sure you check the live video on FarmJo Tutors YouTube page. All right, so let's check some other techniques of differentiation. I'll be giving you two other techniques of differentiation today, and I want you to pay attention to me critically. In the last class, I told you already that the derivative of a constant function will be zero. What am I saying in essence? If I have derivative of 5, 5 here is a constant with respect to x, the derivative must be what? Must be zero. If I want to find derivative of, let's say with respect to t, derivative of x with respect to t must also be what? Must also be zero. So we concluded on this and we checked this in the last class. We also saw in the last class, we saw sum and differences of differentiation. That means if I want to find the derivative of, let's say, 5x plus exponential s. So we have sum of two functions. We have 5x, this is a kind of function. Exponential x is also a kind of function. If I want to find the derivative of this, it's the same thing as finding the derivative of 5x plus the derivative of exponential x. So the first one was derivative of constant function. The second one was derivative of sum or product. It can be sum or difference, sum or minus. It can be minus, whichever one. So yeah, the derivative of 5x should be 5, and the derivative of exponential x should be exponential x. But today, I'm going a step further. I'll be checking the number 3 and the number 4. The number 3 and the number 4. So the number 3 will be quotient and product. We'll be checking quotient and we'll be checking product. So let's start with number 3, product. So we call it product rule. Product rule. So let's assume that I have y equals to u of v, where u and v are functions. They are functions of x. So I have y is a function of two guys. This u is a function of x, v is a function of x. What I'm saying there is that this u you see me right, we can write that u, that is, I can write u as u of x, and I can write v as v of x, such that here our x is the independent, our v is the dependent. Don't forget that I told you that in differentiation, we are finding the rate of change of the independent with respect to the dependent. Of the dependent with respect to the independent. So I will find dv ds, the rate of change of the dependent with respect to the independent. Don't forget that. So here we now have y being a function of the product of two functions, u and v. What is linking them is multiplication, unlike where you did the addition and the subtraction. So in this case, if I have y equals to uv, what will now be then? What will be my dy ds? Don't forget that y is a function of u and is a function of v, but u and v are functions of x, and u is a function of x, v is a function of x. So if I want to find dy ds, I will need to first find, I will keep u, differentiate v with respect to x, that's the formula, plus keep v, differentiate u with respect to x. Can you see that? It's beautiful. When you're having product rule, you keep one, differentiate the other, you keep the other, you differentiate one. So let's say we have, let y equals to uvw. We only differentiate one at a time. So if I want to find the derivative of y with respect to x, where u, v, and w are functions of x. So this also should be, let's keep u and v, and we'll differentiate w with respect to x, right? Also, we've kept this one, we've differentiated this. Which other one should we? So let's take u and v and keep u and w. Let's take u and w, let's differentiate v, dv ds, and which one again? So let's differentiate u and keep v and w. So we have vw and we have du ds. So that's just the beauty. When you are using product rule, you ensure that you are always differentiating one at a time. So when y is a function of three guys, our addition will be in 3. Notice there is no subtraction there. Don't put subtraction in between them. When I have u and v, I only have two of them. So now let me ask you, if I have y being a function of uv, let's say I have y being a function of uvwx, how many will I have? 4, because I have 1, 2, 3, 4. I want you to write this one in your notes, and then you will show me like this. The way I've written this, I want you to write for u, v, w, and x. So let's take a typical example to illustrate what I've said. So let's take an example. So example, they said let y be equals to 6x squared sine x. Find dy dx. See this, y is 6x squared sine x. Find dy dx. So here we're having indices, then we're having sine trigonometry. So solution, if I want to find dy dx here, this guy is like our u here. Our u is like 6x squared. Our v is like what? Sine x. You must be able to break your products into individual functions that they are. Don't forget that. So if I now want to find my dy dx, my dy dx should be, let us keep 6x squared. Keep 6x squared, differentiate sine x. Can you see that? Plus, now keep sine x, differentiate 6x squared. Very beautiful. So I should have 6x squared. Derivative of sine x with respect to x should give me, from our last class, that should be cos x plus, rewrite your sine x. Derivative of 6x squared with respect to x should also be what? 12x, because 2 will come down and you reduce the power by 1. So finally, we can say our answer is 6x squared cos x plus 12x sine x. I just have to bring this one forward so that it will make much mathematical sense. So it's very direct. If you have two of them, you keep and you differentiate order. You keep and differentiate order. Let me give you one more example under this product rule. So let's check example 2. Example 2. I believe you got what I just said. So this time around, I will make it 3. I want to make it 3. And let's now say I have y equals to, let's say, ln x, exponential x, and let's do cos x. So here now I have 3 guys. Solution. I have u. Let's call our u ln x. Let's call our v exponential x. Let's call our w cos x. So if I want to find dy dx, what will I do in this case? Because this is logarithm function, exponential function, and trigonometric function combined together, and we are using product rule. So I will keep 2, differentiate 1. So let us first keep ln x exponential x, and let's differentiate cos x. Are you following? So plus, let us, we've kept this and this, we differentiated this. So let us also keep this and this, and we'll differentiate w. So let's keep ln x cos x, and we differentiate exponential x. Plus, now which one that one should I keep? This and this, and I will differentiate ln x. So plus exponential x cos x, then I differentiate ln x. Beautiful. So here now I should have ln x exponential x. Derivative of cos x with respect to x should be what? Minus sine x. Don't forget that special function, the table I gave you. Plus, I have ln x cos x. Derivative of exponential x should also be exponential x plus exponential x cos x. Derivative of ln x from the table I gave you is what? 1 over x. So finally, if you want to write this together, our final answer, which is our dy dx, should now be minus ln x exponential x sine x. I've brought the minus forward, plus ln x cos x exponential x plus exponential x cos x over x. Interesting. So this is what our final answer should look like. This is all about product rule. Product rule because those functions are matched together by product, and if you want to differentiate them, You differentiate one at a time. You don't match them together, one at a time. So briefly, let's go to the last one for today's class, which is our quotient rule. Then I'll give you my classwork that you'll be submitting to me. So let's check number 4, which is our quotient rule. Quotient, I know by now you should already know what I'm trying to say. That means I'm trying to say fraction, right? So when I say quotient, you should already know that I'm trying to say fraction. This time around, the two of them are side by side, and what is linking them together is multiplication. But here now, let's now assume we have y equals to u over v, now in fraction form, where u and v are functions of x. They are also functions of x. Then what will now be my dy dx? So in this case now, my dy dx should be v du dx minus u dv dx over v square. This is a formula you want to master for quotient rule. Quotient rule cannot be in 3. You can't have u over v over w. It's not possible. It has to just be in this form, in fraction form, u over v. So what does the formula say? Write the one that is under first, differentiate the one on top, minus, write the one on top, differentiate the one under, over the square of the one under. That is the formula. So listen again. You write this, differentiate the one up, minus, don't interchange this thing. You can't write u first and write v here. Your answer will be negative of the original solution that is intended. So let's take an example to illustrate what I'm saying. Example. So they said let y equals to, let's take exponential x over sine x. They now said find dy ds. So this is quotient already, is in fraction form. But don't forget again that what makes this quotient function is the fact that sine x must not be 0, right? Once sine x is 0, this function becomes what? Undefined. Don't forget that. That must be at the back of your mind. It becomes undefined. So in this case, if I want to find my dy dx solution, let's find dy ds using the formula. This is the formula here. So we said firstly v, here now our u is exponential x, our v is sine x, right? And I told you, you write the one under first, which is what? Sine x. Then you differentiate the one of exponential x, minus, you write exponential x, you differentiate sine x over, then the one under v squared, which is what? Sine x all squared. Interesting. So let me rub off this part. So all I'm doing is to just follow the formula. Do you understand that now? Just stay with the formula. Make sure you memorize the formula and you are good to go. So our dy ds is now sine x. Derivative of exponential x, I told you, it's like a stubborn boyfriend that is calling you. It can't change. This guy cannot change. That's still exponential x minus exponential x. Derivative of sine x, that's what? Cos x over, then we have sine x all squared. So maybe you want to make your work beautiful. We can have dy dx based on the option you've seen. Exponential is common here. Exponential is here. Bring out exponential. Then you have what? Sine x minus cos x over. In your trigonometric class, I told you sine x all squared is the same thing as what? Sine squared x. So we can leave our answer like this. Beautiful. Let me give you one more example and I'll see how you're following. So let's take example 2. Let's take another beautiful example. Example 2. So we have y equals to, which example should I give you? Let's take ln x over x plus 2. Then I'll say find dy dx. Y equals to ln x over x plus 2. Find dy dx. So again, this is quotient. Let's identify. Our u is ln x. Our v is what? X plus 2. So if I want to find, this is our solution. So if I want to find dy dx, dy dx, according to the formula, we said what is here? V, which is x plus 2, you differentiate with respect to ln x, you differentiate ln x with respect to x, minus, then you have ln x, you differentiate, what's it called now? X plus 2 over, what will I write next? Thank you. I see that you're following me. Then I'll write x plus 2 all squared, because we said v squared. We kept the first v, differentiated second minus. Do you understand that now? So this should be dy dx equals to x plus 2. Derivative of ln x is what? 1 over x. I know you're following. Thank you. Minus, we have ln x, derivative of x plus 2. We'll do this one after the other. What's derivative of x? That is 1. What's derivative of 2? That is 0. So this guy should be 1 over x plus 2 squared. So let's write the final answer here. Then our dy dx from here now should be x plus 2 over x, because when this multiplied, that will be over x, minus ln x times 1. That should be ln x over x plus 2 squared. Most times, you don't need to expand this one. Just leave it as it is. Don't need to expand. But to make this more beautiful, based on whatever option they might have given you, we can find the xm of the one on top here, so that I can have x plus 2 over x minus ln x over 1. If you take the xm of that one without the denominator, what is common to them? X. What will you have here? X plus 2 minus 1 in x, x times ln x ln x, then over the entire denominator, x plus 2 all squared. I know somebody is squeezing her face already, that what is happening here? All right, don't be confused. What I did is to work on this numerator. Do you understand that now? That numerator gave us this. Can you see it here? It's still the same thing here. I found the LCM, it gave me this. Then I now brought in my denominator, which is this. So the whole work now should now be x plus 2 minus x ln x. Can you see that? Over the x can now come down. x plus 2 squared. Are you still confused? You can pause the video, take it backward, and check again what I've done. So it's like you having a over b over c. It's the same thing as having a over bc. Just like you say a over b divided by c. That's a over b times 1 over c. Do you see that? That's what has happened here. So you have x plus 2 minus x ln x over, so the x has dropped. So miss this guy. So that's our final answer. Now, let me give you my classwork. And I expect you to submit this classwork to my DM, my WhatsApp DM. And at the same time, beyond these questions I'll be giving you, you can find more questions under these topics, under this concept, and study more. So I'll be taking from my notes questions, and I want you to do it yourself. Find, or let's say differentiate with respect to x. Differentiate with respect to x, number 1. So I brought interesting ones for you. Y equals to 7 exponential x cos x. Number 2, y equals to ln x over exponential x. Number 3, y equals to ln x sin x exponential x. And number 4, y equals to sin x over x plus 2. So let me briefly ask you, for what condition will this guy become undefined? When exponential x is 0, right? And this guy can never be undefined, because for every value of x, you keep getting value, you keep getting answer. And where will this guy become undefined? Where our denominator is 0. And where will it be 0? When x is equals to minus 2. That's just to remind you of the function that you've done before. So I want the solution to all of this in my DM. after watching this video. So if there's any question you want to ask, you can make sure to ask a question, type in the YouTube video in the comment section there, we'll pick it, or in my DM, you can ask your questions. Thank you very much.